Once our tripod is level, we're going to take the Theodolite from the box and offer it up to the top of the tripod, again using the locking screw to hold it into place. Remember, the locking screw is to be finger tight and not to over tighten it. Now we're going to try and use the 3 adjustment screws to bring the bullseye level into the center circle. So remember, using these screws, these 2 screws in together or out together to bring the bullseye level into the center, and then using the single screw to bring the bubble directly into the center. So again, using the 2 adjustment screws in together or out together with the thumbs to bring the bubble in line with the circle of the bullseye level, then using the single adjustment screw to bring the bubble into the center of the bullseye level. On the Theodolite, we have our bullseye level, and that's set up correctly, but we also have a secondary bubble level here on the instrument itself. This second one is set up to a higher degree of accuracy. So the bullseye level down here is kind of a rough or coarse measurement for how horizontal or flat the instrument is set up at. Here, this instrument, this spirit level, bubble level here is set to a higher degree of accuracy. For us to use this instrument correctly, this bubble level must be set correctly in between the 2 markers. To do that, again, you align the instrument up with the 2 adjustment screws that you're using, and either in together or out together, move the adjustment screws, in this case by a small amount because the bubble level is nearly correct, so that the bubble is in between the 2 markers. Once the spirit bubble is within the 2 markers, we turn the instrument 90 degrees and we repeat the procedure for getting this bubble within the 2 markers, but this time we're just going to use the single adjustment screw. So no matter where we turn the instrument, the bubble should be in between the 2 markers. Just check it at several locations. Given the bubble level time to respond. Checking it at several points. Now the instrument is set up, ready to be used. To describe the elements of our digital Theodolite, we have an eyepiece, lens, we have a sight on top of the optic, and we have a number of adjustment knobs. On the eyepiece, we have a focus ring for the crosshairs. On the actual body of the optical lens, we have a distance focus ring, so whenever you're looking at your target, you'll bring it into focus using the adjustment of this ring. Here we have a number of adjustment knobs. This is a vertical adjustment. Here it comprises 2 parts. The inner ring will lock the instrument so it cannot be moved in a vertical manner. You can rotate it up and down. With the lock applied on, you can no longer move it. And then with the inner adjustment knob, you can move the eyepiece up and down by small amounts so you can target your prism exactly. Likewise, this is the adjustment knob, or the lock and the adjustment knob for the vertical axis. Turn it around. Here we have the adjustment knob for the horizontal axis. So they apply the lock so the instrument can no longer be turned around, apply it on, and then you can use the second adjustment knob to rotate the instrument by a small horizontal angle. Note for these fine adjusts for the horizontal and for the vertical angle, they will not function unless the horizontal lock is actually applied. So with the horizontal lock off, this fine adjust doesn't have any effect. The lock has to be applied first before any adjustment will actually take place. We have our bullseye level digital display. Here we have an optical plummet. So looking through this eyepiece, we will actually see a point on the ground directly beneath the prism. The Theodolite, like a total station, has two ways to record angles. What I mean by that, either face left or face right. Initially, we take angle measurements in the face left mode. What I mean by that is face left, looking through the eyepiece, where is the measurement part of the instrument? The measurement part of the instrument is this side here. Or an easier way to describe it is the battery pack. Battery pack, this is the battery pack. So wherever the battery pack is, the measurement side of the instrument is on the other side. In this case, looking through the eyepiece, the measurement part of the instrument is on the left. We're recording this angle. When we look through our target, looking at the prism, we're recording the angle in a face left mode. We will then turn to target our second prism and record the angle. Once the angle has been recorded, we'll then flip the instrument, turn it 180 degrees, turn the eyepiece 180 degrees, so we target back at the same second target. Now the measurement part of the instrument is on the right hand side, so now we're recording the angle in a face right mode. Target the prism, record the angle, turn back to where we initially were and target the prism in this case and record the angle. Again, this is in a face right angle. Then we go to our booking sheet, we can work out the difference between the two angles and take an average. The reason for doing this is that if there is any calibration issues with the instrument, by measuring it face left and then subsequently measuring the same angle but now in a face right mode, angle there, back to there, any calibration issues will be eliminated. So that we're using the instrument correctly, we need to have the crosshairs that you see through the eyepiece in sharp focus. This is to reduce parallax. So you take a plain A4 page, hold it in front of the lens, and with the focus on the eyepiece, we adjust it back and forth until the crosshairs are nice and sharp. With the horizontal and the vertical locks removed, we're going to use the sight on top of the instrument to target or point towards the target that we are using. So looking through the target remotely, you'll see a little white triangle, and we're going to aim the point of the triangle towards the target that we are using. In this case, it is the center of the prism. Then we can apply the horizontal and vertical locks and then move to look through the eyepiece. Looking through the eyepiece, we can use the distance focus ring to bring the object into focus, and then use the horizontal and the vertical fine adjust to bring the prism into line with the target. Back to our display, and we can then set our zero angle. So a double press of the 0Z angle, we set the horizontal angle to 0, removing the vertical and horizontal locks. We can then move the instrument to target our second object, using the sight again to line it up before you look through the eyepiece. Apply the horizontal and vertical locks, and then look through the eyepiece and use the fine adjusts to bring it exactly into the center of our second target. In this case, it's going to be a second prism. Looking through the eyepiece, using the distance focus, we can bring our object into focus, and then using the fine adjusts, we can move the crosshairs so that in this case it is exactly in the center of the prism. Looking back at the display, we can record our first angle of being 38 degrees, 43 minutes and 50 seconds. This first angle is recorded in a face left manner. Remember, the measurement part of the instrument is on the left hand side, the battery being on the right. With the angle recorded, remove the vertical and horizontal locks, rotate the instrument 180 degrees, rotate the eyepiece 180 degrees, target back on the original object using the sight to line you up approximately. Apply the horizontal and the vertical locks. We can then look through the eyepiece and target the prism exactly. Using the distance focus, we can bring the prism directly into view, and then using the fine adjust, we can move the crosshair move the crosshairs exactly in the center of the target. The way the instrument is set up, the measurement part of the instrument is on the right hand side, and then we can go and record the third angle, third horizontal angle, 118 degrees 43.20. And then we're going to go back, remove the horizontal and vertical locks, go back and target the initial prism in this case. We use the sight initially to get it lined up so you're pointing in the right direction. Once you're pointing approximately in the right direction, you apply the horizontal and the vertical locks. Then you can look through the eyepiece and then use the fine adjusts to bring the crosshairs onto the target exactly. Using the distance focus, we bring our target into focus, the center of the prism. Then using the fine adjust, we can move the crosshair target into the exact center of the prism. Then we can record the final angle, which is 179 degrees 58 minutes 30 seconds. When we are doing our measurements, there's a way for us to actually record the angles into a booking sheet. Initially, when we set up our theodolite at point A, we looked at the prism at point B and targeted the theodolite to prism B. We would say when we fill in the booking sheet, our instrument is at point station A and we observed our target at station B. We zeroed the theodolite, and here we record an angle of 0 minutes, 0 degrees, 0 minutes, 0 seconds. The theodolite was then rotated clockwise and targeted on our second target, prism C, and the horizontal angle recorded. When we did that, that gave us an angle of 38 degrees, 27 minutes and 0 seconds. Both measurements to start off with were done with the instrument in face left mode. The theodolite was then rotated round 180 degrees and the eyepiece rotated so that you are now looking back at prism C, but the instrument was in a face right mode. Angle recorded in that situation was 218 degrees, 27 minutes, 20 seconds. Theodolite was then rotated back to prism B and the horizontal angle recorded. That was 180 degrees, 14 minutes and 30 seconds. So when filling in part of the booking table, we fill it in. First we do our two face left measurements, zero it, rotate and record the angle, flip it round to its face right, record the angle, back to the original target, record the angle. So you're filling in the angles in like a U shape in the 4 cells. To do calculations with the angles, which angle we actually use, because we've actually measured the angle twice, we take the difference between the two face left measurements and write it in the red box. So difference between 38, 27, 0 and 0 gives you 38 degrees, 27 minutes, 0 seconds. Doing the same with the two face right measurements. The difference between 218, 27, 20, 180, 14, 50. The difference there is 38, 12, 30. You can see the two angles are reasonably similar, but the angle we'd use in further calculations is the average of these two angles. So type in your 38, 27, 0, add to that the 38, 12, 30, add them together, divided by 2, and the average of those two angles is 38 degrees, 19 minutes, 45 seconds, and this is the angle that would be used in further calculations. On the side of the strip instrument is the optical plummet. So here with the optical plummet, you will look with your eye through here, and with a prism in the body of the instrument, prism in here, it will then enable you to look directly beneath the instrument through the locking screw to a point on the ground that is directly underneath the instrument. This is used whenever you're trying to set up over a pin, or you're trying to get a distance measurement between 2 points. 2 rings. This ring doesn't move, doesn't adjust anything. This ring here will bring this sight that you see when you look through the eyepiece into focus. Previously we've used a crosshair as our target. In this plummet we have a circle with a dot in the center, so it's a slightly different type of target. This adjustment ring on the outside is used to bring the focus ring and the target circuit dot into focus whenever you're looking through it. Here you can see the circular ring and the dot in the center, and the dot in the center, the smaller ring in the center, is used to align the instrument directly over a known point or a surveying point in the ground. For our measurements, we'll want to know want to measure the distance between 2 stations. So one way to do it is to take your foot and to gradually reduce or move your foot back until your top of your toe is at the center of the inner ring, and then a colleague can mark that point on the ground with a piece of chalk. Using a tape measure, we can then repeat that at a second station and use a 50 meter tape measure to measure the distance between the 2 stations.